I've been involved in during the course of my career. I called it Keep It On Track, or You Can't Park Here. And the reason I said you can't park here, you look at some of the photos, you'll see some trains parked in some unusual positions, and it reminds me of some of the comments that I make as I'm driving. So that's the reason that it's got you can't park here. So my career started 47 years ago on the railways. I began work at Stratford, East London, in what was at the time the Permanent Way Design Office in the Divisional Civil Engineers section of British Rail. During the course of my career, I spent most of my time overseeing safe operation, design, maintenance of the railway, and keeping trains on the track. But occasionally things do go wrong, and this is some of those things that have gone wrong over the course of my career. I've been involved, although fortunately not. I don't think I've had can say I've caused over 50 derailments over the course of my career. In fact, that number is still creeping up. There was a derailment in Manchester last Friday, which I've been asked to get involved in. So it's probably approaching 60 now. There's several themes and common causes to the derailments, and you'll see as we go through. There's some repetition, which probably means that we didn't necessarily learn, or it didn't sink in. And actually, over the course of 47 years, things come round again. So you'll see that in some of the presentations. But many of the findings have been used to improve standards and hopefully to improve safety as well. So in the drawing office, that's a very young me back in '97. I initially actually started in something called the Crow's office. That was a computerized renewal of way. I spent 6 months in there and never saw a single computer. Now you compare that to the industry today, and we couldn't exist without computers. So in the drawing office, when I moved into there after my 6-month induction in the Crow's office,
you're muted. Bob, you've just gone on mute.
Yeah, hopefully that's come off. I don't know how that happened. After being in the Crow's office, I went into the track design office. So we did surveys, lots of track designs, but we also went out to various incidents that occurred, including derailments. And to support those, we used to do something called a write-off survey, which was top alignment, cant, twist, and so forth. We also had to go out to fatalities, and we did drawings for court cases and serious injuries as well. So it was quite varied in those days. And during the course of my early career, I came across, we used to work with Derby Research, BR's research team at Derby, which at the time was led by Mike McLaughlin, who's still a very keen PWI member, and he still teaches on the diploma courses. So one of the earlier derailments that I was involved in was in 1979 at Brentwood. I don't know if Kate's still watching, but I know she lives in Brentwood. This was an oil tanker train that derailed, and it was caused by a twist. And actually the gang were out there rectifying twists when the train derailed. So it was an early lesson how if your correction of twist faults, you get it wrong, you can actually cause more problems than you solve. You can see the top photo there. It was, I think they were 40-ton, somewhere that sort of region, short wheel-based tanker wagons that came off, caused an awful lot of damage. And in the photo below, you can see a wheel set on the platform. Very lucky in that particular case that nobody was on the platform. That was the up main platform. It's not normally used during the day, and fortunately there wasn't anybody on that platform. Otherwise that axle, which is probably something of 2 tons, would have just wiped them out. Fortunately, now we see very few short wheelbase vehicles like that, but at the time, short wheelbase vehicles were very prone to derailment. And you notice the PPE at the time, we had nothing like all orange like they have in the Network Rail organisations today. And the office attire was a white Mac and a briefcase. Moving on to 1980, you'll see these are generally chronologically in a chronological order. 1980, there was a freight train derailed at Stratford Central Junction, and this is not 1980, the photo there, but it is Stratford Central Junction. It was caused by buffer locking on a sharp reverse curve. I think they were AV switches, which were front to front. And you can see in the photo there, we've still got front to front switches, but they are significantly further apart. So the risk of buffer locking has no longer exists in that layout like it did. But the junction consisted of these very sharp switches, and that formed an immediate reverse. So as a result of that, restrictions were imposed on the certain vehicles that could use that route, but not all vehicles. And shortly after that, there was a derailment of 2 brand new Placer USP 5000 regulators that were actually being delivered. And that's quite embarrassing to have a brand new vehicle off like that. But you can see there the section manager, or the PWI supervisor as he was there, looking quite pleased that it actually wasn't a maintenance issue that caused the derailment, but the design of the junction itself. So we banned the use of USP 5000s operating over there until the layout was remodeled. 1981, our local depot for Stratford DCE was in Temple Mills. It called Leighton Depot. The arrow there points to where the depot would have been. No longer exists today, but we were often, as teams from the drawing office, we were often over there checking layouts to go in the following weekend. And I was over there one Thursday and saw a freight train exit the depot, and in doing so, it derailed. It jumped off, and you can see the Grampus wagon there, or a Grampus wagon. It wasn't the particular one that jumped off, but you can see the sort of wagon that was involved in the derailment. I witnessed the train jump off, and then it re-railed itself and continued on its journey. And this was in the days before mobile phones and anything like that. So actually trying to stop a train when it was heading away from you was quite a challenge. I had to run to the nearest signal post telephone, get in touch with the signaller, and ensure that the thing was stopped. Unfortunately, it was stopped before it reached the main line at Stratford. Otherwise, it would have caused further damage, because one of those wagons was minus a buffer. So the cause of that one was a very worn rail in the S&C, which allowed the wheel flange to strike the fish plate and the S&C blocks, and in doing so caused a wheel unloading, which combined with a track twist actually brought the wagon off. But quite fortunate that the wagon jumped back on again. And also, that's not the only one during the course of my career where a vehicle has jumped back on again. 1983, there was a derailment at Pitsea Junction. It was a passenger train that derailed on the junction, and it was a junction that I'd been the technical officer in charge of the renewal just a couple of years earlier in 1980, 1981. And you can see there the junction being relayed in the 1980s. In those days, we used to relay all of our S&C piecemeal, effectively pretty much like a jigsaw. All the rails were numbered. Each joint was numbered, so the 2 joints had the same numbers. You had to join those together, and the sleepers were numbered as well, and you had to make sure that the spacings were correct. So you can see the new S&C in that particular one is a switch diamond where the personnel are around, and the old track, because it was relayed in stages, a single slip on the right hand side with old timber bearers on top of it. The bottom photo shows the sharp curve that Pitsea was on, and leading into the platform there. And the platform there, the maximum cant in platforms on BR in those days and Network Rail today, 110 millimeters. I think we had 115 in the platforms there, so very slightly higher, but very heavily canted curve. So having just relayed that junction, I was quite concerned that it was a track issue that had caused this derailment, and there's a young technical officer there overseeing the installation. But fortunately, it was not a track issue. It was caused by a vehicle issue, and in fact, it was a wheel issue where something called a Gibson ring. And you can see the diagram on the right hand side shows where the Gibson ring is. Gibson ring effectively is a giant circlip that holds the tyre in place on a wheel. And a lot of wheels these days don't have them, but in those days it was a significant feature. That had broken, disintegrated, and allowed the tyre to come loose on the wheel as it went through the S&C. And the wheel took the wrong side of the crossing. Fortunately, that train was stopping at the station, so there were no serious injuries, and actually the damage was relatively minor. In 1984, I was then working at Liverpool Street for the permanent way maintenance engineer, what we would now term the track maintenance engineer. I was the PTO, the principal technical officer. Our office was just above Liverpool Street, above the stations there, and it bridged across all the platforms. 4 o'clock one night, the Essex, I used to term it the Essex Express to Clacton, one of the main express trains, was leaving platform 12 when it became derailed. And being in the office just above, I was the first rail personnel on the scene other than the driver and the guard. So managed to help to detrain the personnel and the passengers, and then started to establish the cause. And it was actually wide gauge on decayed timber sleepers in the dark area of the platform at Liverpool Street. And you will see as we go on, a good number of years later, that similar theme reoccurs at Liverpool Street. 1987, there was a train collision at Forest Gate in East London. A passenger train derailed when it passed a signal at danger and collided with a train in advance of it. And that particular one, there were 14 people injured. I don't believe any of them were seriously injured, but to have anybody injured is is a serious issue in the railways. The incident occurred in October when there was heavy leaf fall and damp conditions, and the site there, if anybody knows Forest Gate, it's all in cutting, so it holds the moisture, and it resulted in a lack of adhesion. And you can see there the rail, that photo was taken by me at the time. The rail is black with leaf mulch, which is a common sort of symbol if you are suffering with the generic term of leaves on the line. The photo to the rear there shows the cutting, and in the retaining walls with actually quite a few leaves left on some of those trees, but obviously there was sufficient that had come down and caused that adhesion problem. My involvement in that was that I went to site. I did the survey of the site for to try and establish what the cause was, and also did the tribometer readings, which in those days that was actually quite a rare thing to have to do. And I also sat on the investigation panel into the incident. 1992 to 1993, I became the permanent way maintenance engineer for the London Tilbury and Southend line. Some called it the Crab and Winkle line, others called it the Misery line. Today, that position we would term a TME, track maintenance engineer. In that first year in the role, on February the 14th, a train derailed leaving East Ham Depot. It actually derailed in the siding and dragged out onto the down main line and damaged half a mile of plain line, some S&C and a bridge girder. And that actual damage to the bridge girder is still visible today if you know the London end of East Ham car sheds. So on that particular one, I carried out the investigation and established the cause was wide gauge on track within the depot, and spent the evening assisting the recovery and planning of repairs. And the reason for the heart there is, if you see the date, that's actually Valentine's Day, and I should have been going out that night. Any decent young guy would have been taking out his young lady, but unfortunately I was stuck on track assisting the repairs. 1993 at East Tilbury, there was a passenger train derailed in the snow, and this is something that doesn't happen very often in this country. The derailment was caused by very heavily compacted snow and ice through East Tilbury level crossing, and that compacted snow and ice lifted the battery box underneath one of the carriages, which then raised both wheel flanges and was sufficient to cause a derailment. So that was quite a rare one for this country, unfortunately something that we don't get very much of. In 1994, I moved to what we term south of the river. It was privatisation, and I joined Railtrack as their track engineer for initially the Southwest region, or Wessex region as it is now, and that eventually joined with the South Zone, and I became the track engineer for the Southern region. We had quite a few incidents in the course of my time there. The first one in 1994 was a passenger train derailed on wide gauge in S&C, and following this incident there was a major review of the track inspection on the Southwest Zone, and we found that actually the poor track inspector had an incredibly difficult task to do, inspecting the track in and out of Waterloo, which in those days was done under traffic. So you can imagine, if you know the layout into Waterloo, it's a very complex piece of S&C as well as plain line there, very, very busy. So the track inspectors, the patrolmen, were looking out for trains as much as they were for looking out for issues on the track. And for whatever reason, this particular wide gauge had not been picked up. So as a result of that, we introduced a process where we blocked one line during the day, which became the place of safety for the patrolmen. And as the week progressed, that line progressed over from one side to the other on the track layout. So during the course of the week, all of the track could be safely inspected, and the track patroller had a place of safety to go to without having to cross more than one line. 1996, there was a derailment at Farringdon. Farringdon wasn't on the Southern, it's actually on the Midland. But as I was in the office at Waterloo, I was the nearest rail track engineer, so I attended site. Passenger train derailed on a newly installed switch. And the interesting thing about this, it was a very sharp radius switch. It was manufactured from manganese steel, as compared to a lot of our switches in those days that were carbon. And the switch itself had formed and worn into an angular profile on the gauge corner. So there was a sharp corner to it rather than a nice curved gauge corner like you would normally expect on a rail. That gauge corner, that sharp corner, managed to dig itself into the tyre of a freshly turned wheel on a motor bogie. The freshly turned wheels tend to be a lot softer, they're not work hardened, and they also tend to have a slight grooving around where the wheel has been turned. And this particular one being a motor bogie, power was put on, and the effectively it managed to spiral itself out with the sharp gauge corner digging into the wheel, and then climbing up the rail itself and derailing. So this type of failure was known through that incident as a Farringdon edge failure. It's for those familiar with Rail Tracker now, Network Rail standard 053, which is the standard on the derailment risks in facing switches, it became Hazard 5. So it is now forms part of an intense inspection regime for facing switches to eliminate that sort of derailment risk. It was very similar actually to derailments that occurred at Dinting near Manchester and Glasgow Central in the early 90s. So it was a fairly new phenomena that was had just been discovered, but fortunately the findings were rolled out and included as part of the switch inspection process. 1996, there was a derailment at Harring, at Hoffield, and the train dragged through in a derailed state right through to Charing. So that's something that's a couple of miles long. The train derailed on poor top, and the investigation that was carried out by the Derby research team identified the fault as cyclic top, which in those days was a relatively new phenomenon. A lot of work was done to investigate that, and it was found that these continental ferry wagons fitted with a suspension known as a Brunninghouse suspension were prone to derailment at certain speeds, and that's generally above 40 miles an hour. So the dips were at roughly 9-meter intervals, half a rail length, and the frequencies were just such that it excited the vehicle's suspension so much that the energy built up and caused the vehicles to start to almost fly, but to jump up and derail. So this derailment and the investigation that went into it increased the knowledge of cyclic top faults and resulted in the initial measuring of cyclic top by the track recording trains. Prior to that, we didn't have a way of measuring cyclic top. It was just deemed bad top. And the introduction of differential speed restrictions for certain types of track top faults of a cyclic nature. So now if we've got cyclic top, we will tend to introduce a 30-mile-an-hour speed restriction for freight type vehicles, and passenger vehicles don't tend to be affected in the same way, so often we can run those at a higher speed, often line speed. But a lot of research went into that one, and the standards were developed from them for cyclic top. 1997, this was a horrible derailment, I know, but no derailment is nice, but this was certainly one of the worst ones that I've had to endure during my career. It was a freight train that derailed, and the derailment occurred on longitudinal timber bridge. And you can see there the photo, the 100-ton wagons, which were full of spoil, a former engineering train, derailed on the right of that picture, and then ran in a derailed state and pushed through the parapet of the viaduct and ended up in the roadway below. The cause of that was decayed longitudinal timbers combined with an overloaded speeding train. And the reason why it was one of the worst incidents I've had to endure is you can see there those derailed wagons sprawled all over the roadway below the railway line. And for some 48 hours after that incident, we didn't know if there was anybody underneath those wagons. The heat-seeking equipment was brought in by the fire brigade to try and detect whether anyone was there, but the fire brigade explained to us that actually a human body, and it's obvious really, doesn't remain warm for very long once it's died. So we didn't know if anybody was under that lot, and that is a horrible thing to have to think about over a space of time. Fortunately, there wasn't anybody trapped underneath it. There were a few people that were injured, and you can see all the spoilers spilt all over the place on that left-hand photo. The right-hand photo at the top, you can see the damage to the arches there. Well, it's not only the parapet that's been taken away, it's actually some of the arches. And actually trying to find bricklayers in this day and age that know how to reconstruct arches was a real challenge, and one of the biggest issues that actually in recovering that, once we recovered the wagons, in recovering the infrastructure during that incident. But out of all incidents comes some positives, and during the course of the investigation there, the police managed to find a number of stolen Rolls Royces that have been stored away in the viaducts beneath the derailed train. So there is a slight positive on that one, but it isn't a very nice one. And the bottom photo, I think that's me just behind the wagon there, ringing in to report and saying yes, it is derailed. 1999 was a derailment in Strood Tunnel, a little bit different this one. A passenger train derailed on debris that had fallen from the tunnel. And the Strood Tunnel was originally a canal tunnel, which was converted when the railways came along and converted into a rail tunnel. It was not lined originally, and it was cut through chalk. And it was one of these lumps of chalk that had fallen from the roof of the tunnel, and a train struck it and was derailed. This was a passenger train. Obviously, with all these incidents, originally they are declared a scene of crime, and it is some time before we're allowed to get in to carry out investigations. But I was the first member of track staff allowed into the tunnel to investigate the cause and the damage. Following that one, a long-term 20-mile-an-hour speed restriction was applied. And if you know Strood Tunnel, there are two tunnels there. There's Strood and Higham. Very small gap between them. Probably over a mile long when you add the two together, and a 20 miles an hour speed through that adds a significant time to the timetable. So there's a lot of disruption. A further fall fell, a later fall fell in the year 2000, the following year, and eventually the tunnel was relined in 2004 and the speed restriction taken off. 17th of October 2000. Again, this is another day that as track engineer I shall never forget. And we had an incident in Southwest Zone, or Southwest Route, what is now Wessex, at Pooley Green level crossing near Egham, where a bus drove across the crossing. The exit to the crossing wasn't clear. The bus couldn't get off. Fortunately, the driver got all the passengers off the bus, but a train came along and struck the bus, and you can see there the damage as a result of that. The bus itself went into what I think was probably the crossing keeper's hut at house at one time, and took out a good bit of the wall of the house. In terms of investigation, it was obviously an operational incident as opposed to an engineering failure. But there was quite a bit of damage and recovery as far as that went. So I went back to the office. I spent the day there. I went back to the office about 6 or 7 o'clock in the evening, only to get a call. And if anybody recognises that date, that was also the same day as the Hatfield train derailment, where sadly 4 people died. And so the investigation soon found that Hatfield was caused by a broken rail. So that was an infrastructure, and the broken rail was caused by rolling contact fatigue, gauge corner cracking we used to call it in those days, but rolling contact fatigue, RCF. And like many track engineers, I was called to support a lot of the investigation work and inspections throughout the network. At the time, we didn't understand just how big the RCF problem, rolling contact fatigue problem, was throughout the network. On the Southern, we were aware of a few sites, and probably like most regions, aware of a number of sites, but until we did real detailed investigations, the true scale of the problem was not fully apparent. And it was only once we'd done those real detailed, we did a lot of briefings to personnel so they understood what they were looking at, and then sent them out to look, and they found site after site. And those that were in the industry at that time will know that the speeds that were applied across the network virtually brought the country to a halt, and certainly the rail network to a halt, because there were 20-mile-an-hour speeds all over the place, and it just wasn't possible to maintain a timetable in a lot of locations. So I worked with the HQ team to develop the new standards for managing RCF. Initially, we had something called PWI 1, Permanent Way Special Instruction 1 through to 4, and now that's all encompassed in Network Rail Standard 001 for managing RCF. Also, I was called as an expert witness for the prosecution, which is an unenviable task, I have to say, and appeared in court at the court case, which was not for a further 5 years. Now, the photo on the top there, you can see the train that derailed, killing those 4 people, and struck overhead masts, which was actually what caused a lot of the damage to the train. And in the bottom, it's probably not a particularly good photo. That's from, I think, the RABE report, or the Department of Transport report. It shows the rail shattering into lots of pieces, over 100 pieces that rail shattered into. And that is one of the big risks with rolling contact fatigue. It's not like a standard rail brake, where very often you can run a train over it, and once you know about it, obviously you've got to restrict trains running over it, but lots of trains can get over a standard vertical broken rail. This particular type of defect, the rail fractures into lots of pieces, so the vehicle, the wheel, loses all its steering and can go all over the place, which is exactly what happened at Hatfield. And that train was doing over 100 miles an hour when it derailed. In 2001, we had a passenger train derail at West Sutton. It was caused by wide gauge. You will notice how many of these derailments are caused by wide gauge, and you just question why we struggle to manage wide gauge so much and prevent it. And this particular one, though, was caused by corrosion and failure of a lock spike fastening on a Pan 8 base plate. Pan 8 base plates have 3 lock spikes that are driven into the sleeper. They don't have a screw, and those spikes, if water gets on the underside of the base plate, so it sits on the interface between the top of the timber and the base plate, that can cause the spike to start to corrode. Now, that corrosion isn't visible to the patrolman. So in this particular case, all 3 spikes had corroded away, and the gauge was lost. The retention to the gauge was lost, and the train derailed. Following that, a management special instruction was put in place for Ban 8 base plates, PWI 11. I attended court. We were prosecuted, both AMEC and Railtrack, as it was in those days, were prosecuted under the Health and Safety at Work Act. And I appeared, I went to court for that. I was fortunate I didn't have to go into the witness box for that one. And the fines involved were relatively small. 30k for Railtrack, £30,000 for Railtrack, and AMEC were fined £40,000 plus costs. And there's the report on the right hand side. 2002, another very serious incident, as you can see there. That's Potter's Bar in the photo. But prior to that, on the Southern, we had a derailment at Charing Cross. This was a derailment of a passenger train on the river bridge across the River Thames. And I attended site and established the cause on that one, which was again gauge spread, but this time on longitudinal timbers. This particular bridge, the timbers were retained by cleats, which were should be welded to the bridge itself, or should have been. They had corroded away, and there was little actually retaining the timbers. There were also no transoms present, and normally you would expect to have at least transoms and tie rods, as well as cleats to hold longitudinal timbers in place. So that resulted in a major review of the longitudinal timber bridges across the Southern region, and we found a number, particularly in the Kent area, that were non-compliant to the typical standards that you would expect. An interesting thing on that night as well, I was on site all night, and that was the night that the Queen Mother was lying in state, just across the river. So I should remember that one. Potter's Bar, passenger train derailment. The derailment caused by a wheel set taking the wrong side of a switch at high speed due to poor maintenance of the points. I was called to that to support the investigation, including a number of trials that we had set up around different routes of a similar stretcher bar setup to see if we could replicate the particular failings. And you can see there that track on the left hand side, the kink after the set of points where the derailment occurred actually in those points just preceding that, the left hand turnout, and you can see the kink in the alignment at the heel of those switches, and then the next derailment and the next vehicle derailed after those points, causing another significant kink in the track. Another very sad day for the railways, that one. Merston Cutting, 2003, a very wet year. We had a passenger train derailed on a landslip, and you can see the landslide there. That brought a train off in the cutting there at Merston. There was a similar derailment occurred in 2007 that occurred close by, and this was when a root ball from a tree that had been felled forced the King Post wall to fall across the track. King Post wall is something similar to the small retaining walls that you can see there in that photo. So a large root ball came down with the soil as well and struck the retaining wall, and the vertical members of that wall came down and caused a derailment. In 2003 at Redhill, again on the Brighton Main Line, there was a passenger train derailed on the Up Fast line. This is the Up Fast line in the photo. The derailment was caused by a tamper inducing a misalignment into the track during engineering works, and this wasn't identified when the possession was handed back. I carried out the site investigation and sat on the formal investigation panel as the track expert for that one. But why wasn't a big kink like that, which was probably slightly made worse by the train derailing over it, but nevertheless, the tamper left a significant kink there. But why wasn't that detected? Well, the reason was that the tamper finished its work directly over that spot where the kink occurred. And the crew looked out the front window and saw a good alignment. And they looked out the back window and saw a good alignment. But what they failed to recognise was that the actual good alignment that they'd tamped was actually building up a significant slough, which ran out underneath the tamper. And as a result of that, we introduced an instruction that once tamping is finished, the machine has got to run well clear and check that all of the track has been covered and inspected and is compliant. 2004, Sutton Common, passenger train derailed, and you can see the train in the picture on the right there, upon buckled track. Quite a significant buckle, this one. You can see it on the left-hand, the upper left-hand photo. This was newly installed track. We'd had a blockade on that particular piece of railway that had only just been given up a couple of days before. Again, I attended the site and established the cause. It's not difficult to establish the cause on that one, which was recently renewed track. And you can see from the photos, it had at that stage, it hadn't been fully ballasted. The trains are travelling downhill, down the gradient there, and braking. And the effect of those traction forces, or the braking forces, forced the rails and the sleepers through because there was lack of ballast actually restraining them, and caused the stresses to build up, combined with the hot weather, which caused the thermal expansion of the rail and caused that buckle to occur. But an embarrassing derailment when the line has only just been relayed and it's been closed for a significant amount of time. Now, I covered the Hatfield derailment in 2000, but this is the court case. So you can imagine having to wait 5 years to go to this sort of thing, knowing that you were going to be called as an expert witness for the prosecution. The evidence involved 10 rooms full of bundles of evidence. I was questioned on minutes of meeting 5 years earlier. So if you're ever involved in anything like this, or you ever take minutes, or you ever chair meetings, make sure you take good minutes of those meetings, because I mean, I struggle now to remember what I was doing yesterday, to remember what I was doing and what I said 5 years earlier in particular meetings became a bit of a challenge. But certainly I was questioned on that in the witness box. And there was 146 pages of transcript from my appearance in the witness box. A lot of witnesses had a lot more evidence and transcripts taken from their time in the box. But it's certainly, as a track engineer, I would never wish anybody to go through having to undertake or to go through a court case like that. 2006, Waterloo, September, we had empty coaching stock derailed on a facing switch when entering a siding. The switch had been poorly machined and poorly reprofiled. This is another embarrassing one. October, so a month later, a passenger train derailed again at Waterloo on a switch. So this was actually in service rather than an empty coaching stock. And again, it was a poorly profiled switch with a lack of lubrication. So a lot of work was done following this to improve the management of the profile of the switches, particularly when work had been carried out to them, and also involved lubrication as well. That was one of the few RABE reports that actually covered 2 derailments there, and you can see the report on the right hand side. Diagram there on the left, the upper one shows the route of the first train derailment, and the lower one shows the passenger train derailment. Also in 2006, we didn't have a very good year in Wessex that year. In September, there was a passenger train derailed on S&C at Epsom. I attended the site and we established the point of derailment. It was caused by poor track geometry, with associated sideware of the railhead. And on the right hand side, you can see there the sideware and the poor geometry on that joint. This was towards the heel of switches, and you can see actually they had tried to do some blending of sideware, but quite poorly there, and it wasn't sufficient to prevent a derailment. Also note in this particular one is the amount of metal swarf that you can see that's been ground away from potentially both rail and wheel, and sitting in the foot of the rail. That's always a good indication, or a bad indication, that things are not right. 2007, we'd merged the Southern with Anglia, and it became the Southeastern Territory, and I was the Territory Track Engineer for the Southeast. When we had a derailment at Ely Dock Junction, there was a derailment of a freight train that partially demolished the river bridge over the Great Ouse. And if you know Ely, a lot of reliance on the rivers around there, and we upset a lot of boaters because not only did we close the railway line, but we closed the Great Ouse as well. And you can see there the aerial view, the scale of the damage, the loaded wagons, and the upper view, the wagons on their side on the bridge itself. Fortunately, the wagons didn't go into the river, but I think some of their load probably spilt in. We were lucky on that one that we had a wheel check site on the approach to Ely, between March and Ely. Whilst I attended the site to check the track, it was within maintenance limits. There was a slight twist, but it was within maintenance limits. That twist was on a curve. But the wheel checks data actually showed that the vehicle was not only adversely loaded, but was twisted as well. And you can see there the wheel checks data, those big spikes show how unevenly loaded and how that vehicle was twisted. So we could prove there that it wasn't a track defect, but a vehicle defect. Now, I've spoke about Liverpool Street before, 2013, in darkness again. A train derailed, leaving Liverpool Street. And in fact, it was a points failure that we were originally called to. By this time, I was the IMDM, the depot manager at Romford, responsible for track, signalling, overhead line as well. The points failure occurred, and my S&T team attended site, and the initial feedback from them was they couldn't quite work out what had happened. They thought there might have been a derailment, but there was no train on site. There was no derailed vehicle then. So I was called down there because I was only at Stratford, so not very far away, and I established, yes, there had been a derailment. And you can see there in the yellow box, this is from the RAIB report, the area that the derailment occurred was on a very sharp curve on the switch diamond. So there's no check rail there, and actually that curve is below the minimum what we would normally design to these days. The train derailed there and re-railed itself where the furthest arrow is pointing to 2035 points. So not only did that train derail and re-rail on a set of points, it completed its journey to Norwich, which is roughly 100 miles, up to 100 miles an hour. So the curve there was 125 meters in the switch diamonds. You can see there the lower, the left-hand diagram, the red marks and the ones that's got a red circle around show the derailed bogies, which re-railed themselves. But the other red marks on there show the wheels that were very close and probably also derailed and potentially re-railed themselves. So this train went through, the passengers obviously got quite a rough ride leaving Liverpool Street. I think some of the roofing panels may well have come down. Passengers got hold of the guard told the driver, and by this time the train was approaching Shenfield. So he stopped the train at Shenfield, had a look around it, couldn't find anything wrong, and continued on his way to Norwich. And it wasn't until that train got to Norwich that it was inspected in some detail, and the various marks were identified that showed that the train had derailed. And you can see there the train re-railed actually on a fish plate. In 2016, I left Network Rail and I set up a small consultancy, and I now often support insurance investigations. This one was Hazell in near Birmingham. A container train was derailed again in wide gauge, but in a privately owned siding. The container train was dragged onto Network Rail's infrastructure, and it caused considerable damage to both the privately owned depot and Network Rail's infrastructure. And I carried a report out and identified that actually the cause was wide gauge of that derailment. Another wide gauge one. And you can see here the sort of things that you look for with wide gauge derailments. On the left there, you can see the shuffle, what we call the shuffle as evidence. That base plate has been shuffling backwards and forwards as wheels sets pass over it, and causes an indentation in the top of the sleeper, and it causes some effectively that sawdust to build up as well as muck. So you can see that base plate has been moving from side to side. But also on the right hand side, you can see that chair screw, that AS chair screw, has actually sheared at the interface, or just below the interface between the base plate and the sleeper. Again, if you look closely, there's some leaves there, but you can see the shuffle marks, which give you evidence that gauge is moving. In 2019, I was called by the Hong Kong government to support an investigation on their behalf in Hung Hom, which is in Kowloon in Hong Kong. Passenger train derailed. The derailment was caused by wide gauge following maintenance activity. So this is another one where maintenance had been carried out, not particularly effectively, and had allowed the gauge to widen. And you can see there the track, the train is spread right across what is probably their main terminus in Hong Kong. There was, I think, 4 people injured in that incident, nobody particularly seriously. But the timbers themselves, I have never, and these are hardwood timbers, I have never seen hardwood timbers in such a poor state. And you can see those timbers there. They were collected for evidence for my inspection. But on the bottom left photo, you can see the elongated holes that allowed the gauge to, well, it doesn't hold the screws, and allowed the gauge to move quite significantly. I spoke about swarf. A metal deposit. You can see the huge amount of swarf around that check rail in the bottom right photo, and also the broken check rail on the top right photo, where wheels have been striking that end of the check very, very hard before derailing. 2020, Wanstead Park freight train derailed. Initially, the cause was being blamed on longitudinal timbers, which was only part of the story. I walked back a lot further. It's always important when you have a derailment to look back and see if there's any evidence, any witness marks on the preceding track. In this particular case, there was. So it was clear that something was happening before that train reached those longitudinal timbers. And eventually that was identified as a vehicle issue and a issue with the timbers. And you can see the timbers themselves are pretty rotten underneath, which had not been fully detected. 2020, I got called back out to Hong Kong to investigate a light rail, a tram derailment. And actually, the Hong Kong government wanted me to do a review on best practice for light rail maintenance of points around the world, which I didn't want to look at. Unusual one about this, I mean, there are very short 25-meter radius switches, 2 sets there at this point of derailment, but they have something called an outside check, which I'd never come across before. And this outside check is designed to push the wheels flanges away from the switch toe to minimize the wear, which to a certain extent it did, but didn't go far enough. And once the wheel had cleared, the back of the wheel had cleared that check, then there was obviously hard contact with the switch rail. So the wheels are not designed to have that part of their contact with the rail. So it's an interesting where they came up with that design. This is a quick video of a derailment at, if I can get it to play, derailment at Thames Gateway. Not very often you get to see a train derailed, but this is a particularly one, a Freightliner coming in. Christmas tree lights in the background, so you can tell it was just before Christmas in 2022. And here goes the wagons and tipping over there. Now, I was called in to investigate the track on that particular one, and actually the track was in very good condition. You can see on the right-hand photo there, very good alignment. The very slight piece of alignment there was caused by the derailment itself. It wasn't like that before. But Rabe did a very good detailed investigation into the performance of these wagons, which were pretty much brand new, and found that there were issues with their suspension, particularly when they were unloaded. So restrictions were put on those wagons. 2022, I got called back to Hong Kong again, a place called Yang Mai Tai, YMT as the locals call it. A passenger train derailed in a tunnel, and the derailment was caused by a fallen structural component. And the advantage of having forward-facing cameras is that here you can see that structural component, which actually was a derailment guard, had fallen down. So it was ironic that something that was designed to limit any damage from a derailment actually caused the derailment. And I was asked to investigate not only the cause, but actually if they got anything else on the MTR system that could cause a similar sort of derailment. And coming a bit more up to date, Vassigiar in Sweden, 2023, a derailment of a loaded iron ore train. I got asked to go out by the insurers of the train. The train was owned and operated by LKAB, which is the local iron ore mine operator. The LKAB insurers wanted a full report. The derailment ripped up or damaged 15 kilometres of plain line, which included 25,000 sleepers, 3 turnouts and a snow shelter. And you can see some of the damage to one of those turnouts in that photo. Temperature there was something like -25. The cause of the derailment was actually a broken wheel, and you can see that axle there on the right hand side. That wheel is okay, but the other part, you can just see a bit behind that wheel, that is the other wheel that has actually shattered. And you can see the resultant stack of wagons piled up underneath a snow shelter. It was a 32.5 ton axle load, so that compares to our maximum axle load over here in the UK of 25 tons. So it was a very heavy train of 60 wagons. That line was closed for 8 weeks while they did the repair, and this is the first train through the site. So there was a lot of celebration when that train ran, especially as it was causing something like 15 million US dollars a day in failed traffic movements. So it was costing the mine a lot of money. And when you consider that had been closed for something like 8 weeks. So that was the 20th of February 2024. And on the 27th of February 2024, I was called back out to Hazell when an empty derailed train, a train operated by LKAB, derailed. So this was an empty one. This particular one, and I had mentioned the derailment caused by snow in Tilbury, East Tilbury at their level crossing. This particular one was caused by snow and ice, but ironically in a snow tunnel, a snow shed. Now the reason you have a snow shed is to protect the track and stop snow getting in there, but you can see the gaps around the top, and also there were some panels missing on the side of the shed, which allowed a very heavy fall of snow, and it was a particularly heavy fall of snow to go in there. The train had been stopped in the snow tunnel, and in front of it they were clearing snow from around points around the station area, and whilst it was creeping through, one of the wagons actually climbed up and derailed, and you can see the ice on the right hand side there, how strong that is. So that's bringing you reasonably up to date. I think I have been to a couple of derailments since then, but that's just about a quick canter through some of the derailments that I've been involved in and some of the more interesting ones. So I'll open it up for questions.
Okay, if anyone has any questions, can they use the raise hand function, and we'll go. Andrew Starr's got to know if you can unmute yourself and raise your question first.
Hello, Andrew.
Hello, Bob. There are calculations that you can make, which I've seen published and quoted, about vertical forces and horizontal forces and how they would lead to estimations and predictions about climb out. Are they actually any use? Does anybody ever apply those, or are they just theoretical?
No, they are very. Y over Q is what we're calculating when we look at that, and Y is the vertical load and Q the lateral. There are some very good models now, computer models, that do some fantastic simulations of, you can put in the characteristics of the vehicle, characteristics of the track, the wheel profiles and things like that. And Vampire is one of these models that is used a lot to support investigations of the like. So yes, they are used, and very good as well.
Stuart, Corey.
Thank you. With you experiencing a lot of wide gauge derailments, are there any common root causes of this?
I guess the common root cause is diligence on a lot of it. That probably is the most common root cause. There are things where it's very difficult to see visually. But of course, on a lot of our mainline track, we have track recorders, so we should be using the data from there. Fortunately, a lot of them are not these days on mainline, but they tend to be more sidings, and occasionally those siding vehicles, those siding derailments drag out onto main lines. But I would say diligence is probably the most common theme. And I don't mean that to be critical to track inspectors or patrolmen, because we often ask quite a lot of them, and they're required to do quite a bit, but that's probably the most common issue.
Thank you.
Okay.
And I have to say, Stuart, it's very easy with hindsight to come along after, like I do, and say something like that. It's a lot more difficult, to predict exactly when you block the line and so forth, because nobody really wants to take those sort of actions. But it's making sure that people have the support if they feel they need to do that, and take either the actions to block lines or put speed restrictions on. Call others out to get a second opinion is another thing. So
I've got a question. Do you find freight vehicles derailing more often than passenger vehicles?
yes, it's a very quick answer to that. Yeah, I mean, the few that I've been involved in this year, they're all freight vehicles. That's not necessarily the vehicles themselves. In some cases, the track as well. But of course, the loadings are generally significantly higher. Forces are higher. Sometimes it's a maintenance issue with the vehicles themselves.
Okay, John, right?
Yeah, thank you, Bob. Just answered one of the questions, which was going to be the reason why freight are more likely to derail. Some other question was a technical one. You mentioned earlier about, I think it was a wheel checks system that was recording axles going through an area near a junction.
That's right,
yeah. What's the purpose of that? What is it looking to record, and the significance of why it's located near the junction? Was that to pick up a flow of traffic or combine flows of traffic through that area, or for a particular critical asset? Or just like to know a bit more, please.
Yeah, there are wheel checks located at various locations around the network. Probably not sufficient numbers, but they are really looking at high impact loads. So looking for things like wheel flats, and bearing in mind that your normal axle load is 25 ton maximum. It is possible to see a 500 kilonewton impact force from a very bad wheel flat, which of course can cause a lot of damage to the infrastructure, the track, and structures as well. So they're positioned, they tend to be quite strategically where there are quite large freight flows. The latest ones are, I think wheel checks were originally developed by AEA. It may even have been BR technology, but they were AEA. The more recent ones are a Dutch system called Gotcha. Interesting name, but they are strategically positioned. There are certainly, I'm familiar with, we've got some before trains enter the Channel Tunnel, because obviously Channel Tunnel don't want their infrastructure damaged by any vehicles that are going to have imperfect wheels. So yes, they are particularly for that, but also you can look at loading, and you can look at the data from them. So in that particular case with Ely, the data that you can draw from it, and they're not alarmed for this sort of thing. They're alarmed for wheel flats. So the local control centre signaller will get an alarm if there is a likelihood of a wheel flat, so that he can then stop the train and get the driver to check it. But if you review the data as well, you can look at uneven loading and things like that. So unfortunately, there are not alarms for that sort of thing, and it would be good to see that developed. And interestingly as well, there are systems for recording hot axle boxes. And there is other information you can call off of those as well once you go into the data.
Fantastic. Thank you for answering all my subsequent questions as well. Thank you, Bob.
Okay.
Okay, seems like I don't have any more questions. Oh, one more. Sean's got in there.
Yeah, I was got a question, Bob, about corporate memory and organisation change. You made a number of references to standards being upgraded during the course of various investigations. How do we try and retain that as organisations change, so as that the lessons learned in the past aren't forgotten going into the future?
That's a very good question, and I think it's one that as an industry we really struggle with, because we try and cram so much into people's now with standards, and standards have got so big. Certainly within the Permanent Way Institution, we in our diploma courses that we do, and I lecture on some of those, we do have a part of a module on derailments, and we try and introduce some of the those that are on the course to some of the historic issues. But I think it's true to say there's not many people now that have got a huge amount of experience of derailments, and that's a very good thing. Don't get me wrong. It's almost like broken rails. Some sections, now we've got the broken rail numbers down from what used to be close to 1,000 back in 2000, the year 2000, to well over 100 now. So some sections rarely get broken rails. So if you're not used to managing these things, you sometimes forget the and as you say, the corporate memory sort of disappears. So it's a real challenge for the industry how we keep things like this, and I think the presentation, something like this today, does help, but whether it gets down to the right people is sort of questionable.
Okay, I think that's it for questions now. I'm going to say, on behalf of London Section, thank you very much for presenting. I don't know if everyone can show their appreciation in any way. Either, not sure if it's a reaction button. Yeah, there is. And a few. Thank you very much for everyone for joining. Our next meeting of the London Section will be, I think, in October. Currently, I think we're planning to try and have John Dolan to continue a talk he started last year on American stations. Please look out on your emails for when that is announced and whatever the venue or the arrangements will be for that. Thank you very much for joining, everyone.
Thank you.
Thanks.
Thanks. Bye.